Okay, so now we move on to the industries. So where we can use explicit dynamics. So what are the industries that need explicit solid dynamics? So we can say that most of the industries that are producing some product have some type of use for explicit solid dynamics technology. So the most obvious probably is aerospace and defense, because if you imagine about things happening fast, explosions and extreme loading cases, you often think about the military field. But we can also think about transportation and mobility. So a very classic example in this area would be a full crash test of any type of vehicle. So a car, a train, an aircraft, or other types of vehicles. In the energy field, we have lots of applications for explicit solid dynamics. I can give you one example now, that is the perforation of oil wells. Let's say undersea exploitation of oil and gas. So you have very complex interactions happening on the seabed between the drilling tools and the seabed itself. And this type of thing may require you to employ explicit dynamic simulation to achieve a good level of accuracy in your simulations. In the construction field, well, as you can see from the photo here, you can imagine that the bucket on that excavator is all the time subjected to impacts when it's crashing against the rocks or trying to break something. So it's a very harsh environment to work. And many of these conditions may be simulated using explicit solid dynamics. So another field would be the healthcare, where you are often dealing with very complex materials, so the human body, human tissue. So you may require advanced simulation techniques to represent those materials in a realistic manner. So explicit solid dynamics may be employed in those occasions. Then if we go to the manufacturing industry, so you have lots of machining operations where you are cutting through, removing material, and this type of thing. So those will be involving extreme temperatures and, well, the fracture of the material and the cutting of material. So those are very complex phenomena, and explicit solid dynamics may be the correct solution to simulate those problems. Consumer goods, so you can think about any type of packaged product that may be subjected to some drop tests, for example. So you are studying those products under impact conditions, or even during the transportation, they may be subjected again to impact during transportation. So lots of applications in this type of industry. And then high tech, well, a classical example would be the drop test of your mobile phone or your laptop, this type of thing. Any hand device usually is simulated in drop test scenarios. Okay, so this gives us an overview that, well, most of the industries may have some type of applications for explicit solid dynamics. So let's see some more specific applications now. If we keep in mind that we will use explicit solid dynamics when we are dealing with some extreme load conditions that may involve shock waves, large deformation, impact, fracture, fragmentation, and so on. So we can think about blast wave, detonation, explosions. So not only in the military field, but you can also think about mining, where you have the use of dynamite or other types of explosives. So if you need to simulate those type of events, the technique that you will need is explicit solid dynamics. Then high energy impact collisions. So we have here the figure of a car crash. That's very classic. But you can also think about the collision of any foreign object onto an aircraft. So you have here a bird strike on a helicopter and this type of thing. In ballistics, so you have the study of the projectile impacting a target. It may involve dynamic fracture, fragmentation of the target, and things like that. And also, I mentioned before about health and care. So in that type of industry, you will be dealing with large deformations, soft tissue, complex materials. So I have the illustration here of the deployment of a stent in coronary artery. And on the right side here, I have a soft robot. So that would involve complex materials, soft materials, subject to large deformations and large rotations. Okay, so having seen these types of phenomena, we can also think about many other possible applications. So it's a world of opportunities for application of explicit solid dynamics. And I will leave you here with a long list of possible applications. I hope you take your time and read through and think about those applications and get motivated, because you will probably see something that you are interested, some type of product which you would like to work with. And I'm pretty sure there is some type of application of explicit solid dynamics for that specific area. So here I have examples such as designing sports equipment that are subject to impacts, for example, baseball bats or tennis rackets, this type of thing, very interesting. You can think about lots of manufacturing process, including advanced soldering process, or the design of the tools used in subtractive manufacturing, machining, abrasive process, this type of thing, and many others, as you can see in the list here.